Students, welcome to the next video of measures of dispersion. In this video, we are going to discuss about standard deviation. So let us start with standard deviation. So standard deviation is a statistical measure that represents the rate of divergence from the mean in a data set and is used a lot in trading. Now class, basically first measure of dispersion was range, right? Then range has a drawback is in range we are not taking the frequency, right? We are only taking the x values. Then to overcome this difficulty, we came to second measures of dispersion, and that was a mean deviation. So in mean deviation, what we are doing, we are finding the distance of each point of each observation from the mean value, okay, and then we are taking the only positive value, right? Now the question is, we are taking the distance, right? Distance of each value from the central part, okay, and we are not taking the sign. Now because we are neglecting the sign, it has a great impact on conclusion, okay. Since we are not taking that sign, we are just ignoring that sign, negative sign. So to overcome this difficulty, we have the other measure of dispersion, and that measure of dispersion is known as a standard deviation. So in standard deviation, what we are going to do, in standard deviation we'll find the distance of each value from the central value, okay. Then we get the negative term, right? As we see, if x is 1 and x bar is 5, so 1 minus 5 will give you minus 4. So whenever we get since we are getting the negative values, and to overcome this negative calculation, what we are going to do in standard deviation, we will do the square of each value, each difference value, okay. Xi minus x bar, first we have to find x minus x bar, and then we have to square that value, okay. By squaring, we will remove the negative sign, right? Minus 4 square, so it will give you 16, okay. And then we sum all these values, then we find the total of this x minus x bar whole square values, okay. Now since we square each value, right, hence in standard deviation we are taking the square root, okay. So formula for standard deviation, so if x bar is the mean of x1, x2, so on up to xn observation, then the standard deviation is defined as the square root of mean of squares of the deviation from mean. So formula will be standard deviation, which is denoted by sigma. This is our sigma, right? So sigma means standard deviation, that is equal to root of x1 minus x bar square plus x2 minus x bar square plus so on, right? And this part is we called as summation of x minus x bar whole square upon n. This is for ungrouped data, okay. So we also can write this formula as sigma is equal to root of summation xi square upon n minus summation xi upon n whole square. That means summation xi square upon n minus x bar square, okay. So mostly for simple calculation we are using this term, okay. What we are using the formula sigma is equal to under root of summation x square upon n minus x bar whole square. Okay, for ungrouped data. Okay, then for group data, what we are going to use? We are going to use the formula under root summation fy into x minus x bar whole square upon summation of f, right? We are going to multiply the formula with frequency. Okay, so this can be written as under root summation f into x square upon n minus x bar square. Okay, for group data. So for group data, formula is sigma is equal to under root of summation f into x square upon n. N means summation f minus x bar square. Okay, for group data. Group data means group discrete data and group continuous data. Okay, so formula clear for standard deviation. For standard deviation, we have formula for ungrouped data. It is under root of summation x square upon n minus x bar square. For group data, it is under root of summation f into x square upon summation f minus x bar square. Okay, now steps to find standard deviation. To find standard deviation, first step is find the mean. Okay, first part is find x bar. So if the ungrouped data is given, then x bar is summation x upon n for ungrouped data. If group data is given, then x bar is summation of fx upon summation of f. Okay, so step 1 is find mean. Okay, then second step is find this difference. Okay, so find x minus x bar, then square that value. Okay, and then find total of this column. So second step is first find x minus x bar, then square that value and then find total. Okay, then third step is find mean of the quantity. Okay, so that means find summation x minus x bar whole square upon n, find this value, and last step sigma is equal to under root of this. Okay, so total 4 steps. In first step we will find x bar, in second step we will find the distance of each value from x bar, then we will square that value and then we will find the total of that column. Okay, and then we will find the ratio. We divide this value with total number of observations. Okay, and then lastly sigma is equal to under root of this value. So this is the important steps of finding standard deviation. Now note that standard deviation is always positive. Okay, then standard deviation is independent of choice of origin, means sigma x will be same as sigma d, where d is xi minus a. Okay, now standard deviation is dependent on the change of scale. If you are changing the scale, then standard deviation will be depend on that. So if we change the origin x to a and the scale by c and let di is equal to xi minus a upon c, then sigma x will be same as c into sigma d. Okay, so these are the important notes about standard deviation. Now the next measures of dispersion is variance. Variance and standard deviation is related. So we study this variance along with standard deviation only. So variance means sigma square. Okay, so variance is a variance of x, variance of random variable x, that is equal to sigma square. So this is the relation of variance with standard deviation. Okay, so thus variance is equal to, means sigma square is equal to summation x minus x bar whole square upon n for ungrouped data. Raw means ungrouped data, and that is equal to summation f into x minus x bar whole square upon n for group data. Okay, so relation is sigma means standard deviation, that is equal to root of variance. Since variance is a sigma square, so sigma will be root of variance, right? Now we can see the coefficient. Before that, please make a note about variance. Smaller the variance, greater the uniformity in data, and larger the variance means greater the variation. Okay, if you get the small variance, that means there is a more consistent data. If you are getting a large variance, that means your data is a data showing variation. Okay, then coefficient of standard deviation. So relative measure is a coefficient. So coefficient of standard deviation formula is sigma upon mean, means sigma upon x bar. Okay, and coefficient of variance, that is equal to sigma upon x bar into 100, where sigma means standard deviation, x bar means mean. Okay, so this coefficient of variance is a very important concept, because the coefficient of variance is a measure of relative variability whenever we want to compare the consistency. Okay, consistency of different groups, we compare their coefficient of variance. On the basis of coefficient of variance, we can define which set of data is consistent or variate. Okay, a group of data having higher coefficient of variance is less consistent, and vice versa. Okay, so very important concept, coefficient of variance. So just remember this formula. Coefficient of variance is sigma upon x bar into 100. Okay, standard deviation upon mean into 100. Why we are using this coefficient of variance? We are using this coefficient of variance for comparison purpose. Whenever there is a two sets of data, then to check which one is more consistent, we are going to use coefficient of variance. Okay, so let us start with example. So first example is for ungrouped data. Question is, find the standard deviation for the following data. Data is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so x bar is given, x is given as 1, 2, 3, 4, so on. Frequency is not given, therefore the given data is ungrouped data. Okay, now the first step is finding the mean. For mean, formula is summation of x upon number of observations. So first we have to find the summation of x, means total of x. So total of x is 45. So 45 divided by 9, so 5. Okay, now next is we have to find x minus x bar. Okay, so let us start with x minus x bar. So 1 minus 5, that will give minus 4. Then 2 minus 5. Okay, so minus 3. Then 3 minus 5, so minus 2. 4 minus 5, minus 1. 5 minus 5, 0. 6 minus 5 1, 7 minus 5 2, 8 minus 5 3, 9 minus 5 4. Okay, after getting this value, next we have to square this. Okay, we have to square each value, not the total. We have to square each value. So we have to square minus 4. So we get 16. Then we have to square minus 3. So we get 9. Then minus 2 square 4. Minus 1 square 1. 0 square 0. 1 square 1. 2 square 4. 3 square 9. Again 4 square 16. Then next is total, summation. So summation of this column will be 60. Okay, so now I got summation of x minus x bar whole square as 60. Now we have to divide this value with number of observation. So 60 divided by 9. Okay, and then to find standard deviation, we have to put this under the root sign. So root of 60 upon 9. So that is equal to 2.58. Okay, so for ungrouped data. So with this I am completing this video. In next video we can see the more example of standard deviation and variance. So thank you students.